Okay. Now I'm going to write down the important information on my summary sheet or on my cheat sheet. Okay. Now from previously I have all these equations. Now I have something new. Okay. So to make it simple, okay. Now in series, for series circuit, I have the equivalent. The total resistance is basically R1 plus R2 plus R3. Okay. Now etc. Okay. For parallel, well, let's do it separately. Okay. In series and parallel. Okay. Also in series circuit, the current is the same. The current does not change. Okay. The current is constant. It does not change. The voltage, the total voltage, okay, or the voltage from the power source will be same as the voltage 1 plus voltage 2 plus voltage 3, etc. Okay. Now in parallel circuit, the equivalent resistance will be something like this. Okay. Bracket power of minus 1. Remember, it's bracket power of minus 1. Okay. So the total current will be current 1 plus current 2 plus current 3, etc. Okay. Now the um, voltage, the total voltage will be the same as V1, will be the same as V2, will be the same as V3, etc. Okay. So I just make this summary so we can do. I can show you some examples. Okay. Also, just remember this equation here. Okay. The power equation. Now I'm going to use this cheat sheet later to do some example questions. Now look at this example. Okay, so I have a circuit board here, okay, and I need to answer those questions. Okay, so by looking at the circuit board, okay, it is very strange. Okay, so step one is always to redraw it to a more useful uh, to a more useful um, well, to a more simple form. Okay, so the idea is we have a current when we draw it. Okay, we have a switch. Say if the switch is open, that means there's no electricity goes through. Okay, when the switch is closed, okay, current can go through. Now, so if I have a current go through, we'll assume it's closed. If current goes through here, now the current will split into I1 and I2. Okay, so what it means is I have a parallel circuit initially. So we need to redraw that in a simple form. Okay, so what I'm going to do is I'm going to split up. Okay, I have R1 and R2. Okay, then if I follow after R2, after the current goes across R2, it directly connects with R3. So R2 is connected with R3. Okay, then well it ends. So after current went across R1, it means the current which comes out from R3. So what I can do is I can rewrite it like this. Okay, now done. Okay, so in this way, 240 volts. The resistors are 2000 ohms each. Okay, now in this way, I have redraw Okay, I redraw the circuit. They are the same circuit, but this time it looks more similar. Okay? Of course, with a switch down there. Okay, it looks more simple. Now let's answer question 1. Okay. What is the voltage of R3? Okay, we're looking for the voltage of R3 when the switch is open. Okay, so the idea was when the switch is open, there's no current go through. When there's no current go through, the voltage will be 0. V3 will be 0 because the switch is open. Okay, now let's answer question 2. What is the voltage of R3 when the switch is closed? Okay, now here is a picture of the circuit I rewrote. Now for question 2, I need to find the voltage across resistance 3. Okay, now from what I can say is, okay, I know it is a parallel circuit. Okay, so the parallel circuit would have the voltage will be the same. I have 240 volts across here, and I should have 240 volts, okay, with R2 and R3 together. Okay, so the voltage across it will be, well, given that R2 and R3 are the same, they're both 2000 ohms. So my guess will be R3. The voltage will be divided in half. Okay? Because on the top, the resistance are connected in parallel. In series on the top only. So it will be 120 volt. Or we can do it by using formulas. V equals to IR. Okay, so the current will be voltage divided by the resistance. Okay, so the voltage here, let me name it I2, okay, will be the same. Okay, the current across resistor 2 will be the same as the current across resistor 3. So when I try to calculate it, I should use 240 volts, okay, divide by both resistance, okay, divide by the equivalent resistance of R2 and R3. Since they are connected in series on the top, okay, it will be 2000 plus 2000. Okay, so 240 divided by 4000, cancel it. We're going to have 0.006 amps. Okay. So from this, okay, now V equals to IR. Okay. Now V3 equals to current times resistance 3, so it's 0.006 times 2000. Okay. It's going to be 120 watt. Okay, done. Okay, the main point of this question is, okay, R1 is in parallel with R2 and R. So, let me write it down. So, okay, R1 is parallel to R2 and R3, not with both of them, both two resistors on the top. Okay, so, yep. Okay, now. Okay, now have a look at question 3. Okay, so question 3 asks me to find out, let me change the color. Okay. Question 3 asks me to find out the power, okay, the power of the power source. Okay. So the power source is supplying power to R1, R2 and R3, 3 resistors. Okay. So if I look at my cheat sheet, Okay, power is equals to energy divided by time, Vi or I square R or V square R. Okay, so by looking at this, okay, just let's write down the equation. Okay, I square R Vi or V square divided by R. Okay, so by looking at the equation, I know the voltage, I know the resistance. Okay, I can, well, to make everything easier, I use V square on R. Okay, because I want to analyze the total power from the for the whole circuit. Okay, so I have to use the total resistance. I cannot, yep, the equivalent resistance. Okay, so since we know the equivalent resistance, since okay, sorry, since this is a circuit in parallel, so I have to 1 on R1 plus 1 on bracket R2 plus R3, because R1 is parallel to two of them, okay, which, yep, so then bracket minus 1. Okay, okay, so the idea was if we want to find the power of the whole circuit, we need to use the equivalent resistance. Okay, so if we do the calculations, type it in your calculator, you should have 43.2. Okay, now let's do question 3. Let's do question 4. Let me just erase question 3, and I'm going to start with question 4. So question 4 asks me to find the power of resistance 3. Okay, so as we can know, a power supply supplies electrical powers to all three resistors. Okay, so what's the power drawn by resistance 3 only? Okay, now, well, the equations are there. Okay, we can use either one of them. Okay, so since in question 2, I know power 3 is 120 volts, and I know the resistance of power 3, so just again use this one. Okay, it will be 240, sorry. Okay, so the voltage will be 120 because we're only interested in resistance 3. Okay, so the voltage 120 divided by 2000. Okay, or what we can do is, well, this is too simple. Let's use this equation, V equals to, okay, let's use that equation. So we know the voltage will be 120, the current here, we found it out in the previous question. Question 2 will be 0.006. Okay, so you do that, it will be the same. Okay, will be sorry. Okay, you should have the same answer. Okay, type it in your calculator. Okay, sorry, I think I made a mistake. Okay, now the current should be I made a mistake here. I didn't use calculator, so I made a mistake. Okay, so it should be okay, so it's 0.06. Okay, so the answer should be 7.2 watts, 7.2 joules per second. Okay, you should have 7.2 here. So, yep. Okay. So the question, the important thing is when you're doing this kind of questions, make sure, okay, have a read what the question looking for. Okay, whether they ask you the power of the whole power supply, or the power of resistor 3 or resistor 1 or resistor 2. Okay, so then when you're using the equations, okay, you need to use the values for that device. For example, if I want to find the power of resistor 1, I need to use the current when through resistor 1 and or the voltage when off resistor 1. Okay, so just do some practice. Okay. Okay, here is another example. Okay, in this example, well, we still have R1, R2, R3, 2000 ohms each, and 200 volt power supply. Okay, so what they ask me to do is they ask me to find the total resistance, okay, the equivalent resistance, the total current, and the total power of the power supply. Okay, so well, let's do it one by one. Okay. In this case, okay, now I have a resistor 1 and resistor 2 and 3 are in parallel. Okay. So, okay, and what I do is, however, okay, now treat them separately. Treat resistor 1 as one big thing and treat resistor 2 and 3 as another big thing. Okay. So equivalent resistors, okay, will be R1, okay, plus, okay, the total resistance of R2 and R3 in parallel. Okay, remember this, R2 and R3 bracket, okay, minus 1. Okay, yep, because R1 is connected in series with the parallel set of R2 and R3. Okay, so if you put down the value, I have 2000 ohms plus 2000. Okay, do the math. You should have okay, you should have 3000 ohms, which is 3000 ohms. Okay, so the total resistance is 3000 ohms. Okay, now let's find the total current. Okay, the total current. The total current will be the voltage divided by the resistance. Okay, V equals to IR. So 240 divided by the total resistance. Do your calculation. I better do it right. It should be 0.08 amps this time. Yep, should be alright. Okay. And we need to find the total power. Okay. So this one will be VI. Okay, will be easier. 240 times 0.08. Put it in your calculator. Your answer should be in watts or joules per second. Okay. Now, down. Okay, so, yep. Okay, now let me erase all my answers. Okay, and let me find out the power and voltage of all different resistors. Okay, we have, okay, let me use a different color. We have three, okay, we have three resistors, R1, R2, and R3. So R1, R2, and R3. Okay, so uh, what we did find out, the total current will be 0.08 amps, okay, from last time. Okay. So what's happening is the current would go 0.0 amps of current would go through R1, okay, and after 0.08 current, okay, let me label it properly. Okay. Afterwards, the current will split to I2 and I3. Okay, so the current when through the resistor 1 will be the same. Okay, because the current gets split after going through R1. So I know the value of the resistor, I know the current. Okay, I can find out the voltage of R1. Do your math using your calculators. Now I think it's going to be 160 volt. Yep, it will be, yep, that should be it. Okay, now then I have 160 volt here. Okay, so I have, now remember, okay, now let's look at R2 and R3. Okay, remember R1 is in series, is connected in series with the whole set, with the parallel set of R2 and R3. Okay, so if I have 160 volts here, R2 and R3 should have 80 volts because they should end up to 240 volts. Okay, so also because R2 and R3 has are parallel, they should have the same voltage. So V2 should be 80 volts, also V3 should be 80 volts. Okay, because they're parallel. The whole bunch have 80 volts, then yep, they're parallel, so each of them should have 80 volts. Okay, now I need to find I2. Okay, using the equation V equals to IR. Okay, rearrange it. Okay, V divided by R. Now I know it's 80 volt. I know the current. The resistance. Do your calculation. It should be 0.004 amps. Yep. Oh, yep. It is easy because the resistance are the same, so I should have 0.02 volt. So do the same thing for this. Okay. The answer should be the same, 0.004 amps. Okay. So the idea is if you add I2 and I3, it should be the same as I1 because yeah, they split it from I1. So yep, that's down. Okay, so the power for R1 will be VI. Okay, will be 160 times 0.08. Okay, you find the answer inverse. Similarly, the power of R2 will be V2 times I2 times 80. Well, right. Yeah, I think I made a mistake. It should be 0.4. Okay. Now, oh, yep. Okay. So, yeah, you should have an answer here. Okay, it should be 3.2. Also, okay. Okay, you should have your answer in words. Okay. So this is basically how do we analyze a circuit.